Alright, so in this video I'm just going to do two more examples of solving absolute value inequalities. They take a little longer, so I feel make a really long video, so I'll split it into two. So here's another set of problems. So first thing, again, we always do is try to isolate that absolute value expression, so we have to get rid of this negative 10, which we'll do by dividing, right, because this is negative 10 times absolute value 2r minus 1. Divide by negative 10 here. These cancel out, so we end up with absolute value 2r minus 1. Over here we end up with positive 6. Now remember, we're dividing by a negative number, and whenever we multiply or divide by a negative number, we need to switch the inequality symbol. So it goes from less than or equal to greater than or equal to. So there's our absolute value. Now we're going to split this into two equations, two inequalities. 2r minus 1 is greater than or equal to 6. And again, we're going to have to switch the symbol the inequality symbol when we do the negative version. So 2r minus 1 is less than or equal to negative 6. Alright, now we can solve both of these. So 2r is greater than or equal to 7. So r is greater than or equal to 7 halves. Over here, we're going to have 2r is less than or equal to negative 5, adding 1 to both sides, right? So r is less than or equal to negative 5 halves. Alright, that's a lot of fractions, but I think we can handle it. Alright, we'll represent our solution on the number line first. So we'll put in our two places here, negative 5 halves, 7 halves. We want everything greater than or equal to 7 halves, so we'll fill in the circle and everything this direction, and fill in this circle and everything less than 5 halves. Alright, so that's our solution on the number line. In interval notation, that's going to be, well, this is going to be, over here we've got everything from negative infinity to negative 5 halves. And that's going to be, close bracket over here, parentheses on this side. Over here we're going to have everything from 7 halves, including 7 halves, up to infinity. And then we put those together with the union symbol. Alright, so this set and this set. And let's try one more. Okay, we've got to isolate the absolute value, so we're going to add 5. So we get 9 times the absolute value, 3 minus k, is greater than or equal to 72. Divide by 9, we still haven't isolated it, so we've got to do another step to isolate the absolute value part. So absolute value 3 minus k is greater than or equal to 8. Alright, now we'll split it. 2. 3 minus k is greater than or equal to 8. 3 minus k is less than or equal to negative 8. Right? We're switching that inequality symbol because we're talking about negative. Okay, so let's do this. We've got negative k is greater than or equal to 5. Right, we just subtracted 3 from both sides. And then to get k, we're going to have to multiply by negative 1, and you know that means we're going to have to switch the direction of the inequality. So this is going to be k is less than or equal to negative 5. Over here, negative k is less than or equal to negative 11. And again, we're going to have to multiply by negative 1, switch the inequality, and we end up with k greater than or equal to 11. Okay, so those are our two things there. Now we're going to represent that on the number line. So let's just find negative 5 over here, 11 over here. We've got everything less than or equal to negative 5 first, so that's just going to be negative 5, closed circle, and there, and then everything greater than or equal to 11, and that's over here. Represent that using interval notation. We'll do this part is going to be everything from negative infinity up to and including negative 5. And then union everything from 11 and including 11, that's why it's a bracket, up to infinity. And that's our answer. Okay, that's solving absolute value inequalities.